Hi, right, this X-Wing here is, we're going to turn this into a portable light. We're going to put these lights here are going to go inside, like in here, and somewhere up here we're going to put these lights. They are 20 watt, their mains in, so there's a bit of flicker on them, but we've played pull under them and it's actually fine, because just the ordinary GU10s are the same basic thing. They're going to need mounting on a heatsink, obviously, to get rid of the heat, so we're going to put these on a heatsink. Maybe copper as well to get rid of more heat. We're going to put TMP 102 temperature sensors bolted to this as well to monitor the speed of the heat, because there's no speed wires on these fans. They're just they just spin, so if they stop spinning, the heat's going to go through the roof. So by monitoring the temperature with an Arduino, we can output the display or bleep or do something to, or turn the light off, because we're going to switch these on with relays. So that's kind of like the way we're going to go. I've already disassembled this because the first video didn't come out too good. What I've used is these blades that like just sit in here, and I can just flick them down, because this is a child's toy, so it was designed really not to come apart. So you can get these quite easily with this. This one, these intakes, what I did, I put jeweler's screwdrivers down in this side, so not to bruise it, and then I put the lever down in here, and I've levered it up to get it out. And once you get one side out, the back side just comes out anyway. You know, it's still a bit tricky, but it does come out. What we're going to do with these is we're going to mount surface mount LEDs in here, and control these with an Arduino Nano, and they're going to glow or pulse or whatever we're going to do with those. We're going to add R2's actually got like a plastic insert through the centre that's clear, so we can light the like his eye up, if you like, so we can do things with that. I'm going to put a landing light in here, a surface mount LED in there. For the exhausts, we're going to use, they do at Neo Pixels, do a dual, and it's a 7 LED like round disc, and it just fits nicely in there. So we're going to drill a hole, get the cables through all on the inside of this model. I'll get the other piece out so you can see inside. I'm only making this video really mainly for myself, to be honest, because in 3 years time I won't remember how I did any of this. So there's 12 screws. These ones under here are the worst ones to get, because they're actually under the air intake, air intakes, which would be the hardest ones to get at. There's 12 in total, and then it will just come apart. R2, he clips right in, but he clips in really tight in there, and you're never going to get that out without damaging the model or R2. So you can get him out here, because you can just flick him out from the inside, but I wouldn't even try getting him out from the top. If you've clipped it in, you have to take the model apart to get it out without damaging it. We're going to spray it to weather it so it looks like it's weathered. I'm taking this half down to my mates tonight, so that because I've actually made these lights up, these are just spares. We're going to get these mounted in here. I took a casting of the inside with a plaster of Paris, and then we've cut templates, so hopefully we've got 2 of these models, and hopefully they both survive. But we bought one as a try and get it right, and if we can't, the second one we've got to get it right. But the idea is to put the LEDs in, because they're mains LEDs, put 12 volts in there for the fans, connect up. I've written a little program on a Nano and a little 20x4 LCD, little liquid crystal display. We're going to monitor the temperatures, because this is all going to hang off of cables, so it's going to hang, we're going to put like wires on it so we can alter how we want it to hang over the pool table. But we're going to run it with the lid on, see how hot it gets, and go from there with cooling. We're either going to need to have a fan sitting in here with holes in, so we can just blow air out the back. There is a hole going to be in here for the ribbon cable, to let all the cables in. So whether that's enough to cool it, there'll also be air going through here. There'll be air coming in the nose well as well, won't there? Through here there'll be air coming in. So yeah, I don't know, we're going to try it, see how it goes. Yeah, thanks for watching the video. As I say, I've mainly done this for myself. I'm not like a YouTuber that's going to be doing thousands of videos on this, that and the other. I will go through how I make it, because as I said, it's so complicated that 3 years down the road I need to document it somehow of what I've done. The plan is to use a Mega 2560, which will drive the nose landing lights. We're going to put LEDs in here for the landing lights. They're going to have white LEDs, surface mount LEDs, white nose wheel lights. The exhaust duals are going to get run by Nano. The air intakes are going to get run by Nanos as well. They're all going to communicate on a I2C bus, and we're going to have temperature sensors on the fans, another sensor just inside the model itself so we know how hot it is in there, and another sensor on the boards, because the boards are all going to be up in the ceiling and it's going to come down on a ribbon cable. I've actually got it running. I'll try and document all the boards that's in it, because there's a board in here with no components. It mounts across here, and it's literally just got all the connections in it for all the cables, all the LEDs and stuff, so that there's nothing inside here that's going to go. I've had to use a shifter to shift the voltage from 5 volts to 3 volts for the TMP 102 sensors for the fans. So I didn't want the shifter inside here, because if it goes wrong it means I've got to take the damn thing apart. So everything electronically wise other than the LEDs is in the ceiling, and only the LEDs and some connections in here will be in the model, and obviously the 4 temperature sensors and the LEDs themselves. I watched another video on YouTube where the guy had these things running. He stripped them right down so you can see all the tracks and everything, and he had it running, and he kind of said that these driver chips, if they get too hot, they limit the current that goes to the lights, and the lights just get not so bright. So technically, if it went over temp, it wouldn't be the end of the world, but he didn't actually test one to destruction, so I don't actually know. I did try some little bead LEDs, 5-watt ones, and trust me, they did die. There was no coming back from those when they went too hot, which is why we went with these and the GPU. They're just video graphics card heat sinks, so they shift quite a bit of heat. Anyway, as I say, hope you enjoyed watching.